I don't know if I'm just supposed to start. Is that it? Okay. Apparently you were just waiting for me to pick up a microphone. So welcome everyone. This session is titled something around high quality AI systems for education, from innovation to scale or something along those lines. And thank you all for joining us today. Really looking forward to having you here. My name is Jonathan Stern. I'm the Deputy Director of the Global Education team at the Gates Foundation. And the premise for this session is relatively straightforward, right? The idea is that AI is not, or AI in education is not just about finding tools that work, right? That's a relatively easy thing to do. But what we want to think about is what is the ecosystem that is necessary in order to ensure that high quality decisions can be made about uptake of AI in education safely at scale, and that ultimately improves learning, right? So the reality on the ground in many of the contexts we work in, that the foundation we cover work in sub-Saharan Africa and South Asia, is that it is what people have been referring to for the past decade or more as a learning crisis, right? Many children not being able to do basic numeracy or literacy by the end of grade 4. But that also provides us with an important opportunity, right? And so one of the things that we're discussing here is that evidence-based approaches to the foundational learning issue do exist, right? We have a good sense of what works to improve learning. There's a fair amount of literature on the impact of structured pedagogy and targeted instruction. If anyone wants to go out and read the GEEP papers on smart or best buys, right? There's a lot of evidence around what works. There's also obviously a lot of excitement right now about EdTech and AI in education. And the question is not, is there a space for AI in education? But it's how can we use AI to accelerate the impacts that we know are achievable via proven approaches, right? So it's about solving problems that exist. I think one of the conversations that Ramana and I have had a few times, and others in the room as well, is too often in the EdTech and AI space, you end up with people coming up with solutions and then seeking a problem to solve, right? And we want to think a little bit differently around what are the pain points within the systems that can be alleviated by the use of technology, right? So accelerating impacts, as I said, by scaling proven approaches, improving efficiency, so reducing administrative burdens for teachers, allowing them to focus more on instructional time, providing more access to activities and on-target tasks for students, right? There are a whole bunch of opportunities for AI to come in, but as I noted a bit at the beginning, and as we're going to talk about here, AI in and of itself is not inherently an education solution, right? It doesn't improve learning just by the sake of having it in schools, right? So we want to think a bit more critically about what does it mean to think of quality assurance for AI for education, right? So we're going to hit on 3 main topics throughout this session, right? So the first is on quality assurance and evaluation. So what are the questions we should be asking, the things we should be measuring, and what's feasible in low and middle income country contexts. Secondarily, the role of benchmarks and standards. So what kinds of standards can help, both technical and not, right? Accuracy is no longer sufficient in and of itself. We need to think a bit more about the pedagogical side of standards as well for AI in education. And lastly, what it looks like in reality at scale. And so we have a great example from here in India that we'll be talking about for what that may look like. And so in short, what we're really talking about is how do we generate evidence with sufficient guardrails that travel with a product from pilot into scale, right? And what is that ecosystem that will allow for scalability of AI in education systems? So we have three panelists who will be answering some initial questions, and a fourth guest panelist as well to provide some summary remarks at the end. I will happily let people, if they want to share some additional intros for themselves, do so. But Romana from Fab AI is 2 seats to my left. Mark Schottland from ID Insight in the next one down, and Jiraj from Convigenius at the end. And next to me we have Professor Kalpana Sharma, who's the Vice Chancellor of the Lakshmibai National Institute of Physical Education in MP. Right? And so without further ado, maybe we'll get to some questions, because people probably have no interest in hearing me talk any longer. So maybe, Romana, starting with you, can you tell us a little bit about how Fab AI is thinking about quality assurance in AI for education and what its implications are for scaling?
Mm-hmm. Thank you very much, and hello, everyone. So at Fab AI, we are really looking into how can we use AI to improve learning outcomes, especially in low and middle income countries. And quality assurance is one of our key pillars of work. So let me tell you how we do that, but maybe just one moment to reflect on why we do that. So no one will be surprised in this room probably when I say that already nowadays, millions of children worldwide are using AI tools in schools and outside, also for learning. But, there is a but, of course, we are looking into how many of those have been evaluated. We have, for example, done a mapping of tools in South Asia and Sub-Saharan Africa, and we mapped 352 tools for learning. And you can just think for a moment in your head, what do you think is the percentage that had any evidence on them? Well, what we found was 9%. So that is not a lot, right? Because at the same time, we do know that governments do need to make also high-stakes decisions. We do know how quickly these developments are evolving, and we do know that also developers need to make decisions as they go on. And so we want to help the others to be able to make confidently these decisions. So how we do that is that we're trying to look at quality assurance in a way that we think of the whole product lifecycle. We do think of a cyclical approach because, as I mentioned, as you all know, these things are evolving fast, so it's not enough to do it once. It needs to be a mindset. And then we do want to also do it as a multi-layered approach. And I have just one slide, which should help to make it a little bit easier to follow. But what I want to show here is that we are focusing on the tools, AI-enabled tools for teaching and learning. And when it comes to the layers that I was talking about, what we mean by this is, you can have a great tool, and maybe it passes all the safety checks, but it doesn't mean that it will be a good tutor, right? Or maybe it's a great tutor for English, but it doesn't mean necessarily will be great in other languages, in Kiswahili or any other you can think of. And so that's why we do think it needs layers, it needs to ask questions at the different layers that we put here on the left that you can see. So starting with the global layer, where we think of things like safety or bias, right? That needs to be there. But then we want to look at the education layer. Is it actually gonna improve the learning outcomes? Then you want to be sure that actually, if it is supposed to be an assessment tool, it is good at assessment. And then you need to consider the evaluations for that, the specific metrics, and track those. And then one layer further, and very important, is the context layer. Of course, it can be a great assessment tool, but if it is not aligned with the local curriculum, not with the available infrastructure, or the social norms, it's not good enough. So what we are trying to do is to find these questions, and of course then it is specific to a product, but we are trying to build this ecosystem where we do see how the tools are doing and where they need to improve. And then, as you can see, we do think about it along the product lifecycle. So there are different types of evaluations we do and we promote. And one of them is benchmarks. For those of you who are not so familiar, those are basically how you put the AI models to test, right? And we do have a lot of benchmarks already in, for example, for content knowledge, but there were some which are needed for education that were still missing. And one of them was pedagogical knowledge. So we did look at how can AI models look at the practice and methods of teaching. And we developed the first pedagogical benchmark when we do constantly track and add new models coming out. You can check on FABI website, the leaderboard. And what we want to do here is to show how well they do on real-world teacher exams. So that's how it was built. What we also want to show is how the small models are doing, because of course for the context we are working in, the cost is a big question as well, right? So you can track there and see how they are doing. But we don't want to stop there. We did then look into translating this model into other languages and also seeing what happens. And maybe you would not be surprised. We did do this for Sub-Saharan Africa, but would likely be similar also in India and other contexts. We did see that even for the biggest languages in Africa, like Kiswahili or Hausa, the model performance dropped by 15% on average, right? And it got worse when we looked at small models. And there was another interesting fact that we've seen, is that if we use the AI translations, the performance dropped less. When we used human translations, which we did in Uganda with our partner Crane AI, it actually dropped even more, which shows that maybe we even over-rely on the AI models, right? So why I'm saying this is that we are not just trying to show how the models are doing, but really uncover what are the gaps that we need to fill. And then we do talk with the model developers and try to improve those, right? So that is critical. One other benchmark which is interesting, Jay briefly mentioned, is the visual reasoning. We all know that AI models are really good at solving some of the most difficult math problems. And at the same time, they really struggle with the visual reasoning, which is critical for teaching foundational numeracy, right? So again, these kind of questions which are practical, but if we do solve it, even in the lab setting, when you are coming up with a product, it is much more likely than once you get to scale and to those decisions, if it is built for that, with that in mind, they will do much better. So this is the benchmarks. As you see, we do also look at evals, which are more specific. How well do tools do on specific tasks? We do also then want to make sure that you do co-create with teachers, with educators. You test it through test beds in the real environment, and we will hear more on that also later. And then one more thing that I will briefly just mention is the impact evaluation. We do still think there is space for that, of course. You do want to know how well the tools are doing when it comes to learning outcomes. But there are new questions coming up that we are also considering, such as cognitive offloading, right? Is it happening? And what are the harms, unintended harms could there be? So we do need to measure this. As an example, we are currently doing studies with Google DeepMind in several countries, just concluded some in India and Sierra Leone, and seeing like how can we do more rapid evaluations just to see if there is an improvement, right? When I say more rapid, it's like 8 to 10 weeks. Also, of course, the cost is then lower. So it is one way, which doesn't mean that there is no space for standard RCTs. For example, when you want to see about is that effect going to stay, right? So these are some of the things we are thinking of. So rethinking how you can think more rapidly while still rigorously. What are the areas? And I would say that, yes, generally our mantra is, yeah, what doesn't get measured doesn't get improved. And that's why we are doing that.
Amazing. Thanks, Romana. So a lot on the benchmark side, which is super important and interesting right now. I mean, Mark, can you tell us a little bit about, at ID Insight, how are you approaching the measurement and quality assurance at scale?
Yeah, sure. So I guess I will first preface this by saying there's two primary, I think, technical teams at ID Insight. We have our data science and engineering team, and then we have our research and evaluation team, and that latter team is the one that I lead. But I'll try to answer that question from both teams' perspectives. So the data science and engineering team, they help nonprofits and others kind of build AI into often like digital delivery programs that they have. So for example, and I've also been asked to use some of our examples from health. So I'm going to give a health example, hopefully bringing it back to education soon. So we work with this organization called Reach Digital in South Africa. They had a chatbot that they had produced in collaboration with the Ministry of Health in South Africa. And the chatbot is called Mom Connect. And it's a chatbot for mothers, pregnant and lactating mothers, to ask questions. So mothers can ask questions like, what foods can I feed my baby? Or, I had some spicy food and my baby seems to be kicking a lot. Is that a problem? But also questions like, I haven't felt my baby kick in 2 days, or my baby's coughing and they're turning blue. What should I do? Now, you want models that can basically give you pretty accurate information. So what our team did is they helped build AI into this. What was that substituting? It was substituting a kind of relatively small army of nurses that were manually answering these questions. And so you had a huge backlog and a lot of kind of very urgent questions were not getting answered in time. And so the AI, the kind of LLM aspect of it was being able to answer these questions quite quickly. But, if you're a Ministry of Health, you don't want answers coming from the World Wide Web, right? You don't want them coming from Reddit posts or whatever. Like, you want it to be really good quality information. And you may not even trust like the international standards. If you're the Ministry of Health, you want the information to be coming from your guidelines within your country. And so one of the ways that they ensured quality was basically limiting the information that the model pulled from to the specific guidelines of the Ministry of Health. So that was like one layer of quality assurance. There was also other layers of kind of quantitative feedback when mothers kind of gave a thumbs up to a recommendation or not. We had monitoring dashboards that could look at that and basically say, are these answers answering people questions? But then a lot of times, because the model was constrained to only pick up information from the Ministry of Health guidelines, if a mother asked a question that it couldn't answer, it would say it couldn't answer. And so then we had a whole bunch of qualitative data, like what are the kinds of questions that our model is not answering? And is it not answering because these are not health questions? Or is it not answering because our model is not picking it up correctly? And so that's kind of another layer. We also had another layer of like urgency response, urgency detection. So, the example of a blue baby or a baby that's not kicking for a while, like immediately, send message, seek immediate medical attention, and so on and so forth. So these are some of the layers of quality assurance that we had. We're doing something similar with community health workers in Ethiopia, working with Last Mile Health. And now tying it to education, we are working with the Ministry of Education in Senegal to basically help with a teacher chatbot, produce a teacher chatbot so that teachers can get help designing lesson plans. And again, you want those lesson plans to come from the Ministry of Education curriculum. And you want it to be using things like knowledge graphs and other things. So like if I'm asking for a lesson plan on geometry, this particular concept, the knowledge graph will help kind of it'll know that there is, you have already covered these topics. It's not just gonna kind of invent a brand new thing in a vacuum. It's like, they will know you've already covered these topics in your curriculum, and therefore will give you a kind of quality answer for a lesson plan going forward. So that's the data science side. The research and evaluation side, I realize I'm limited in time, so I'll be as quick as I can. Ultimately, I think we define quality by the outcomes. What are the outcomes? In foundational literacy and numeracy, for example, the outcomes are literacy and numeracy. And so how would we do quality assurance there, or quality assessment? We would do impact evaluations. So that's one thing that ID Insight is a big proponent of, like make sure that we are measuring the impact of these new models. We know lots of things work. We're gonna have an excellent example of a super effective product from Jairaj, from Canva Genius. However, but the things that we know change, context change, language change. How do these products kind of keep up with contextual changes, with scale? All of these are questions that you probably want to reassess with an impact evaluation. Is it still having the impact at scale that it had at kind of a pilot stage, for example? There's also, as models are updating, there's continuous A/B testing that we can do. Is this model improving outcomes faster than others? The one benefit of education that I will say, and this is different from health and other sectors, is that in a lot of cases, the outcomes that you are measuring that you care about, for example, basically student learning outcomes, are actually measured by the app directly, right? If you have a chatbot for a health intervention, that chatbot is not measuring the children's health directly. They're maybe, they can potentially measure the mother's knowledge or other things. But in education, you can actually directly measure some of the outcomes that you care about. And so being able to do A/B tests is quite important. Last, and we'll probably talk about this in the next section, when you talk about interventions at a pilot stage, you want to know whether they're effective. When you talk about them at a systems level, then you need to bring in systems change measurement, and that's a whole nother beast. But I will pause and hand it back.
Excellent, thank you. Romana, so clearly from this and also others in the room, like there's a lot of work already being done in this space, right? And so how do you think at Fab AI about the future direction of the work you're doing and how it's additive and complementary to what's happening or has been happening thus far?
Yeah, so that is right. There is already a lot of work around quality assurance and standards. You might be familiar with some of that. We are monitoring what is out there and looking how we can learn from the others. Just to mention a few great examples, like there is a Tectulna standard here in India by CSF Foundation. We also have the UNICEF AI for Good framework. So there are also frameworks, not only standards out there already, which can be very helpful. And for example, a few weeks ago, we've seen that the UK government has just launched new standards, also looking at areas such as manipulation or the impact on mental health, which are so important, right? So we're looking at everything there is, and yet we do think there is still need for more, for certain components. So what we are looking at is bringing this technical evaluation layer to it, build components on evaluation, and then offer it for the ecosystem to build on, to use that to help them get some thresholds of what you need to aim for. Of course, linked to what I presented before. So we have recently launched this QA fund that we started to work on. Very soon we will be sharing more information on that also publicly. And what we want to assure there is that we do build more of these components. We will build new benchmarks. But we will also do rapid evaluations in the field, and we will want to share this with others. And we will not do this work alone either. We will work with great partners such as ID Insight, who, as you heard, they have tons of experience in doing evaluations. They will help us with all the field work. We will also work with others such as CGD, who has developed a great playbook, which is cross-sectoral. So not specific for education, and that's what we want to break in there. And we will tie this also to other existing networks and alliances, such as one by Dalberg, which will be launched tomorrow here at the summit. So we do really want to find synergies with others and build for the ecosystem to get better at this all together, to solve the issues that we need to solve.
Amazing, thank you. So we've been talking a little bit at a high level thus far about kind of the ecosystem around benchmarks and evaluations. Switching gears a little bit, Jiraj, into what does it actually take to allow for an AI-enabled product or solution to be embedded in a national education system? Can you tell us, as a starting point, just a little bit for those who are unaware in the room, despite your incredible reach already, what you're working on as an AI-enabled edtech organization at Convigenius?
Sure, sure. So we have a platform called SwiftChat, which is powering about 150 million children today across 800,000 schools in India, which is roughly 1 in 2 schools. And the idea here was, how do we get AI to the last mile, right? Like how UPI has done it in fintech, how do we do that for education? Uh, Actually, internet is everywhere, so it's quite possible to build platforms on top of the internet, and it's a matter of time that every household, every school will have AI. So we really was solving the problem of, what's that possibility of building a platform which will reach the last mile. The teachers have smartphones today, they have internet. COVID brought that revolution, right, in India. So that was the window of opportunity for us to bring the power to teach and learn on a mobile device, or every single mobile device. And we went to the fundamentals, right? What is the app that is in every phone in India? It's WhatsApp, right? WhatsApp's messaging, right? So the fundamental layer in which internet's working and almost 300 billion messages are being exchanged a day is on messaging. So conversational AI was there long time back, before even generative AI and LLMs existed. So we started with very fundamental, simple thing like, how do we bring chatbots, which where you can just message in your own language as a child or as a teacher, and you can chat, right? And the tendency for us as humans is that if you have a message on your phone, you want to reply back. So that leads to 99% conversion rate. So that's why it's an extremely sticky interface. Like, you have conversations going, whether it's a human on the other side or whether it's AI, you have a tendency to respond. It's a human psychology, right? And that's very sticky as a platform to be able to teach children, right? So that's why AI tutors on this interface, on agentic interfaces, on conversational AI interfaces, was bound to scale, right? And with large language models coming in, that was an opportunity which has already been seen now. Like, we can have AI tutors that can teach you 24/7. You can just call an AI tutor and you can ask a question in the middle of the night, and so it'll help you solve the homework. So the scale has been pretty much about how do you scale up messaging infrastructure at the fundamental level. It is essentially building like a WhatsApp for education. But what really mattered was quality, right? How do we deliver on quality when you have population scale, children, teachers actually using your platform? You cannot go wrong on anything, right? You have quality matters, the right guardrails, the right quality, the right way you present all the information you're presenting on the platform, the platform policies, the content policies, and the guardrails and the biases that come with it. All of those were important design considerations while you were building the platform. At the same time, actually, learning is a much more complex problem. When we go to learning, we define impact in various levels. Access to quality education is one, where you can say that, we have 10 million users using our platform every day. That's access. But actually, real evidence on learning improvement is the kind of North Star metric for us. And for learning, it's essentially about subtraction, right? How much of the information we can really subtract. We already had a lot of information on the internet, and children could just browse and learn, right? But good systems are able to kind of deliver the right information, what to show and what not to show. Just simple 2 questions: what to show, what not to show, at what point of time, is really pedagogical engineering, right? And added to the fact that we don't have enough time in the school hours, so we are also playing with the variable of school time, right? On a limited amount of time, what is the best way to deliver, say, 0.5 SD, standard deviation of learning outcome improvement? That's the real problem that AI tutors are really chasing and solving for, right? So it's about showcasing, understanding how children learn, and showcasing the right content at the right time. And that's an exciting problem that we have been solving for. Context, as Romana was saying, is very important. What works in the state of Gujarat may not work in the state of Andhra Pradesh. There's a lot of context at the grassroots level, and each of these contexts cannot be captured with just one agent or a one bot. There's multiple bots and multiple transactional data from different bots in that inform the system, right? It's like memory is not just enough to teach and learn. Similarly, understanding, which school they are in, whether the teacher is coming to the class, what they have been teaching, all of that transaction data also informs in terms of how the AI tutors need to respond, right? So it's a platform play, and it's pretty exciting. Yeah.
That's great, Draj. So, you talked a little bit about the opportunity being there, right? WhatsApp, obviously, ubiquitously used, LLMs growing in popularity and accuracy and affordability over time. Romana talked a little bit about what's needed to make decisions for what tools to take up or use. So, can you talk a little bit about the scaling side of it in particular? So in terms of how were you able to achieve such large scale within a government system, right? What were some of the levers that were there, and how did quality assurance, maybe since that's the theme running through this, play a role in that?
Sure. Firstly, I think the most important part was that we tried to do early on and on WhatsApp, but we had rate limiting issues. WhatsApp Business API has a fundamental rate limiting protocol which allows for 30 to 40,000 requests per minute, right, as throughput. That's not enough for even a city like Delhi, right, to be able to run AI agents. So the large problem that we were first solving for is how do we run population scale AI agents, right? And it can keep scaling and scaling. Like how do we do it for a state like a state of Himachal Pradesh or a state of Gujarat or Rajasthan, right? When all of the students are learning at the same time, and if you are having to deliver more than 150 to 200,000 requests per minute, your platform should be able to solve for that. So that's actually at the messaging protocol layer, right? So we have to have native messaging protocol so that you can scale. That messaging can be both synchronous as well as asynchronous. Asynchronous is how WhatsApp operates. You send a message, you receive, and AI chat can happen asynchronously, right? Synchronous, you're calling the AI bot. You can have a voice call or a video call with AI. So that's even more difficult, right? And more expensive. So that's the first layer of unbundling of a platform, which is the ability to communicate, whether it's on human on the other side or an AI on the other side. So communication infrastructure has to run at population scale. The second is that systems in India have their own compliances, data compliances, content compliances, knowledge compliances. You have to be able to deliver for DPDP, which is the Data Protection and Data Privacy Act. You should be able to host personally identifiable information in the customer's infrastructure. So a lot of these essentially require unbundling of the application layer, the transactional data layer, and the knowledge layer, right? So essentially the platform really had to solve for creating an architecture which will actually work for scale in India, where governments and government systems can run their digital public infrastructure and at the same time give the same kind of experience what WhatsApp delivers, right? So there's a lot of value in building infrastructure, right? Knowledge infrastructure, learning infrastructure, teaching assistant infrastructure. And it's really about unbundling based on, how do we solve it for multiple states and as a country as a whole, right? You'll also have to comply with federal policies. Yeah.
Thanks, Suraj. Maybe back to you, Mark, on building on what Dhiraj was saying about the specific use case of scaling with Convigenius, but with the experience that you have at ID Insight on extensive evaluation work and thinking about what that means for system-wide delivery of AI in the education space, what are some conditions that are necessary enablers for that to happen?
Yeah, okay, so first I'm gonna talk about the conditions on the product side and then conditions on the system side. So for the first, I'm going to very shamelessly plagiarize a framework from Kevin Starr of Malago Foundation. He calls this the enoughs. Does it pass the enoughs test? So his enoughs are, is it good enough, big enough, simple enough, cheap enough? So good enough is the question is like, does it actually have an impact? And as Jonathan said, as Jairaj has mentioned, like we actually have lots of evidence on what is good enough, and there's lots of products that are good. I mean, Convigenius is one example of that. There was a study by Michael Kramer just recently published, I think, that not yet published, but recently released. Student outcomes doubled by like over the course of like relative to a control group, student learning outcomes doubled in the Convigenius group over 17 months, more than doubled. I mean, that's huge. So we actually, and we have other products that are showing similar things. So we have lots of evidence of what's good enough. Big enough, that just means, is there a large enough need? Education system, lots of children, obviously a need. Simple enough. Now this is the one where I think a lot of what that gets a lot of interventions. If you have too many moving pieces, too many things that like a teacher needs to adjust on, like this thing needs to fall in place, the teachers need to do this, the administrator, the more complicated it gets, the more likely it's gonna break and it's gonna fail. So if it's not simple enough, it's gonna be very, very, very difficult for it to scale within an education system. And then the fourth is cheap enough. And so, you know, the per student cost at a pilot stage is usually quite high, because there's lots of people kind of checking whether there's, you know, monitoring whether the implementation is being, is following with fidelity, and so on. One of the issues with LLMs is that there's not necessarily economies of scale. As you scale up, you have more questions, more tokens, more cost. And so scaling with LLMs becomes actually kind of a problem, especially if you're operating at this level. And so you now need to start thinking about, okay, do we need to build our own small language model so that we're not constantly pulling from the cloud? So those are some of the conditions on the product side. And then on the system side, you know, some of the basic things that we, there's like an education scalability checklist, VVOB, and lots of others like Pratham and others worked on this. But, you know, the types of questions are political economy, finance, et cetera. I mean, I think one of the most important questions is coherence, right? So if you have a bunch of teachers that think their primary mandate is to get through the curriculum, and then you have an edtech solution that is tailored towards the levels and the pace of actually children learning, and it slows things down. Now you have a teacher that's trying to get the curriculum and a product that's trying to slow them down. That's not coherent. And so those incentives need to change and those expectations need to change. So that's just like one example. There's also lots of issues of like social norms, right? Where teachers are not new to this idea of like a new intervention is going to be, they have to now kind of change their teaching practices slightly. They get new teacher training every year and multiple times a year sometimes. And new things are going to be asked, new interventions, new innovations, and they're going to look around, they're going to look at their peers, and they're going to say, like, is this one going to stick, or is this just going to be another one of the, like, hundreds of attempts that has now been kind of dumped on the heap of failed interventions? And so no one's going to really go through the effort to just, you know, make sure that they're complying, they're learning everything they need to learn, they're using it to its full potential, because if it's gone in a couple of months because no one's paying attention, they're not going to do it. So anyways, I think these kind of like peer effects are quite important and social norms. And so you need to be kind of building that momentum for the motivation quite a lot. And that a lot of that is top down, a lot of that is grassroots. So I guess I'll leave it there so we still have time.
Amazing. Thanks, Mark. So maybe shifting gears, Professor Sharma, in a different light and different part of the sector than we've been talking about, prioritizing the foundational learning space. Can you maybe talk a little bit about anything that resonated with you here that you'd like to recap, or anything you think is essential for your work when thinking about AI in education?
Thank you very much, John. So as introduced, I'm a Vice Chancellor at a university, which is a government university, Lakshmibai National Institute of Physical Education. We are into basically teacher education. And when we are talking about AI solutions for teachers, and I'm sure we are the voice to be heard for the solutions to be created, and hence this voice is here. So we are into teacher education for physical education teachers, for sports teachers, for yoga teachers, for sports management solutions, and other solutions what we are giving at our institution. But what takeaways from here is that yes, when we are preparing teacher educators, how much our teacher educators should be integrating their teaching learning methodology, their pedagogy, especially while dealing a child, especially while handling that child who's going to be healthy tomorrow, who's going to be an athlete tomorrow. And that leads to the second point which I wanted to place was that we are looking for solutions. Solutions largely for those who will be handling athletes, and solution for those athletes who are practicing to be champions tomorrow, because that is where solutions are required. An athlete's training program can be programmed, his daily progress can be monitored, his performance can be analyzed, and he can be given a very good and a faster feedback if I'm sure certain kind of algorithms are developed for them. So this was something which to do with athletes, something to do with teacher educators, something to do with the pedagogy, and yes, the very important is about the impact evaluation, which you mentioned. You see, when we talk about preparing teachers, I was just mentioning yesterday that our scorecards, our report cards, our nursery kids, their report cards, has got two elements, major elements. One is the marks they give, or a grade or a marks. But the second very important thing is a teacher's register. If you go back and, I mean, many of you must be school teachers or university teachers here, the school teacher takes all the pain to describe a child the whole year. I hope AI will be able to give that solution, because that is the personal connect of a teacher to a child. If that connect is not created, we are not nurturing the child towards developing him into a human being for tomorrow. So that model may look a little different when I'm talking what I'm saying, but that's also much needed. And I want to give you a personal example here, because I've been doing a lot of impact evaluation research for the Special Olympics International. Yeah. So I'll take you to a remotest city called Rajsamand. Rajsamand is a small city in the state of Rajasthan. There is a school run by parents of a child who is a 98% cerebral palsy. I mean, and that school is basically for deaf and dumb students. It's a personal visit, and hence I'm sharing of my own personal experience here. We had gone for some data collection there, and those parents were running that school, and in that school there was a lady. Rajasthan is a very conservative state overall, but that lady somehow managed to, a teacher, now there is a teacher, managed to come to that school regularly on a scooty, putting that full gungat. Gungat, you understand? No? Gungat is veil, covering your face, and still driving that scooty and coming to a school. And those children who were studying, I mentioned the WhatsApp here because WhatsApp was that medium where these children were receiving messages from that for teacher, answering the queries, and they were passing in the examinations. I mean, these are the individual examples which you'll find more, and very sensitively where the teachers are engaging themselves in the benefit of our teachers. So I'm just bringing these points so that when we design certain more programs, we have more inclusive programs, and we have more sensitive programs, especially for the ages whom we are going to look 10 years down the line or 15 years down the line. Thank you so much for that opportunity.
So we have 45 seconds left. So my closing will be briefer than I had intended. Instead of reading my actual closing, so I had asked ChatGPT to come up with some memorable lines based on the closing I wrote. And so instead of reading the closing, you'll just get the memorable lines, and you can decide if any of them are actually memorable. One is, benchmarks are not about winners and losers. They're about making decisions that protect children and improve teaching and learning. not terrible. A second was scaling isn't just a bigger pilot, it's about the system, not the product, which I actually really appreciate. And the final one in my last 3 seconds is the goal isn't AI in classrooms, it's better learning safely for every child.
And we're out of time.
Thank you.
All right.
We hit our time.